It takes more rocket fuel to land a spacecraft on Mercury than it does to fly past Pluto. Pluto is 4 billion miles away. Mercury is the planet next door. And yet, in the entire history of space exploration, exactly one spacecraft has ever made it into orbit around Mercury. This is the wrong way around. Mercury is closer than Mars. It's closer than Venus much of the time. If you were sketching out a tour of the solar system from your couch, Mercury would be the first stop. So why have we sent more spacecraft to Pluto than to the closest planet?
The answer starts with a gap. In 1975, NASA's Mariner 10 finished a series of Mercury flybys and went dark. The next spacecraft to visit Mercury, Messenger, didn't arrive until 2011. That's 36 years of silence around the planet next door, longer than any other gap in modern space history.
This wasn't because we lost interest. Mercury is genuinely strange. A tiny rocky world, 70% iron by mass, with a magnetic field where no one expected one, and a surface no one had really seen. Scientists wanted to go back. They just couldn't figure out how.
Here's the surprise. Going inward toward the sun sounds like the easy direction. You'd think you'd be falling downhill. And you are. That's exactly the problem. The sun's gravity pulls everything in the solar system toward it, and the closer you get, the harder it pulls.
The European Space Agency puts it like this. Reaching Mercury at a speed slow enough to actually stop there is like falling off a cliff millions of kilometers high and trying to land softly on a moving target halfway down. The cliff is the sun's gravity well. The target is moving fast. Mercury is the fastest planet in the solar system. It's whipping around the sun at roughly 47 kilometers per second. Earth, by comparison, moves at about 30. So a spacecraft that has finally fallen down the sun's gravity well still has to catch up with a planet sprinting in the other direction. At Venus or Mars, there's a trick spacecraft can use to slow down for free. You dip into the atmosphere, let friction bleed off your speed, and you've saved enormous fuel. It's called aerobraking. Mercury has essentially no atmosphere, so there are no free brakes. Every bit of slowing down has to be paid for in rocket fuel. And that's the death spiral that defeated mission planners for decades. More fuel needs a bigger rocket. A bigger rocket needs more fuel to launch. Brute force Mercury missions priced themselves out of existence. To get to the closest planet, you had to be clever instead.
Clever, in this case, means doing laps around the inner solar system. You aim past Mercury, swing around Venus, swing back past Earth, swing past Mercury again, and each close pass siphons off a little bit of your speed through pure gravity. ESA's analogy is billiards. Long, slow, perfect bank shots across hundreds of millions of kilometers.
Messenger, the first spacecraft to orbit Mercury, did this for 6.5 years. 1 Earth flyby, 2 Venus flybys, 3 Mercury flybys, just to get into position. Only then could it break into orbit. The whole point was simply to arrive slowly enough to be captured.
But getting there is only half the trip. The other half is surviving where you've gone. At Mercury's distance from the sun, sunlight is about 10 times as intense as it is at Earth. The sunlit side of a Mercury-bound spacecraft can reach 450 degrees Celsius, pizza oven temperatures.
Messenger's solution was beautifully low-tech. A ceramic cloth parasol mounted on a titanium frame that hung between the spacecraft and the sun. The sunlit side of the parasol baked at 370 degrees. The spacecraft behind it sat at room temperature. Like sunbathing under an umbrella, except the umbrella was made of fire blanket. Here's a counterintuitive twist. You're parked next to a star. You'd think solar power would be the one thing you had plenty of, but pointing your solar panels straight at Mercury's sun would cook them. Engineers have to tilt them at an angle, deliberately catching less light just to keep them from melting.
BP Colombo, the current mission, has an even stranger fix for one of its spacecraft. The Japanese half spins, constantly, like a chicken on a rotisserie. The idea is that if you turn the whole craft slowly under the sun, no single spot stays hot long enough to bake. Distribute the damage. Survive. For Bepi Colombo, more than 80% of the materials in the spacecraft had never been tested in conditions that extreme. Every ceramic coating, every insulation layer, every antenna, every sun sensor, qualified from scratch on the ground, then sent to find out whether the lab tests held up against a real star. And below all of this, the surface itself. Mercury is the planet with the largest temperature swing in the solar system. Daytime, around 430 degrees Celsius, hot enough to melt lead. Nighttime, minus 180. A swing of 600 degrees in one place every day. And the day itself is bizarre. One sunrise to the next on Mercury takes 176 Earth days. A lander would face nearly 3 months of continuous sunlight, then 3 months of frozen dark. Solar panels would have to survive the night. Most don't. And then, the surprise nobody saw coming. Mercury barely tilts on its axis, so the floors of craters near its poles have never seen sunlight, not for billions of years. And in those permanently shadowed crater floors, Messenger found water ice on the closest planet to the Sun. The same planet that has surfaces hot enough to melt lead has surfaces just a few hundred kilometers away that are among the coldest in the inner solar system. Side by side, if you piled Mercury's polar ice into a spot the size of Washington, D.C., it would be more than 2 miles thick. Which brings us to right now. There is a spacecraft, currently in flight, about to attempt only the second ever Mercury orbit insertion in history. It launched in October 2018. It is a joint mission between the European Space Agency and the Japan Aerospace Exploration Agency. Its name, we mentioned earlier, Bepi Colombo. Bepi Colombo's bank shots have been spectacular. 1 Earth flyby, 2 Venus flybys, 6 Mercury flybys, 9 gravity assists in total, the most of any mission ever flown. The final flyby happened in January of 2025. The spacecraft is now on its terminal approach to Mercury. There was a hiccup. In September 2024, engineers noticed Bepi Colombo's ion thrusters weren't firing at full power. Some unexplained interaction with the spacecraft's electrical system. ESA's flight dynamics team had to replan the trajectory mid-mission, including a closer-than-planned Mercury pass to compensate. Arrival slipped 11 months. New arrival date, November 2026. When it gets there, Bepi Colombo will split into 2 orbiters that fly around Mercury independently. One studies the surface and the iron core. The other, the spinning one, studies the magnetic field. The first time 2 spacecraft will measure Mercury simultaneously. And there is plenty to measure. Why is Mercury 70% iron by mass when no other rocky planet is anywhere close? Why does it have a magnetic field at all? What exactly is the dark material covering the polar ice? After Bepi Colombo, we might finally have answers to questions we've been carrying since the 1970s. But there's one more question worth asking, because it's the one with no good answer yet. Could a human ever go? Mars has a roadmap. The Moon has a roadmap. Mercury does not appear on anyone's roadmap, and the reasons compound. The radiation dose is an order of magnitude worse than Mars. The heat load on a habitat, large by comparison to a robot, is brutal. The round-trip fuel budget is essentially double the one-way budget, and the one-way budget is already at the edge of feasible. There are no parachutes because there's no air. If anyone ever does send humans to Mercury,
The destination is already obvious. The polar craters, floors permanently in shadow, stable and cold, with water ice already on site. And along the crater rims, peaks that never see darkness, eternal sunlight for solar power, eternal cold a few steps below for shelter.
That isn't a plan. It's not even close to one. The technology gap to a crewed Mercury mission isn't incremental, it's foundational. Better shielding, better propulsion, better life support. The kinds of breakthroughs that would unlock the rest of the solar system first.
For now, Mercury stays what it has always been, the planet next door that we've barely visited, the closest one, the hardest one. In November, Bepi Colombo will arrive, and we will have orbited Mercury twice in the entire history of human civilization, which, depending on how you look at it, is either a small number or a beginning.